Alright, so in this lesson we're going to talk about how you obtain the value that is stored at a memory address. In the last two lessons, you learned how to create a pointer and how to assign a pointer the memory address of some variable. So let's examine this code. You should know from the previous lessons exactly what is happening here, but let's review it. First, we are creating a variable called total that is of the type signed integer, and we are assigning it the value of 5. Secondly, we are creating a pointer called PTR and giving that pointer a value of the memory address of the variable total. Because the value of total is 5, if we were to run this command, this function, the output would be like so. Now, we said before that a pointer is useless if we do not have some way to read and use the data that is at the memory address the pointer refers to. So in this lesson we're going to talk about how to do that. Remember that C has an address of operator, which is the ampersand character. Whenever we put the ampersand character in front of a variable, we are saying the address of that variable. So if we write ampersand total, then what this means is the memory address of the variable total. In other words, the memory address where the variable total is stored. Now, if I have created a pointer, it makes sense that I will want to see what is actually stored at that memory address. In other words, I need a line of code that reads something like this. Recall that PTR is the name we gave to our pointer, and it contains the memory address where the variable total is stored in memory. So in other words, using our 16-byte RAM example, let's just imagine that total is 1 byte in size, which it isn't, but it makes it easier to explain. If this is how our RAM looks, and it was 16 bytes in size, then what we're basically saying is that total is located at this position in memory, and there's the value 5. So in that case, the variable PTR is going to contain the memory address in our example of 8, if that's where we're storing it. Now, of course, that's a very simplified example, but it helps to explain what's going on. So remember that the variable PTR contains the memory address of the variable total. So how can we do this? How can we write a printf statement where we can say what is at the memory address of PTR, which is where we have stored the memory address of the variable total? So what we want here is we want the output to be the total. The total is 5. How can we do that? In the last lesson, you learned that you can use the ampersand character to mean address of. It turns out that you can also use the asterisk character to mean what is at the address of. Now, this is in addition to using the asterisk to create a pointer. I'm not talking about that. I'm talking about when you are using some statement where you want to specify what is at the address of a pointer, you can use an asterisk. So in other words, if we write star PTR, we are saying whatever is stored at the memory address stored in the variable PTR. So in this case, what memory address is that? Well, that is the memory address of the variable total. So if we were to write this code, if we were to write the total is %d and we use star PTR as the argument, then what do you think the output would be? Take a moment and look at this. We're creating a variable called total. We're giving it a value of 5. That means somewhere in memory there's a memory address, and at that location in memory is the value 5. Then we're creating a different variable called PTR, and we are giving that variable the value, which is not the value of total, but the memory address where total is located, because this ampersand character means the address of. And then we have a printf statement where we're saying the total is %d, which means it's expecting an integer, and then we write star PTR, which means whatever is at that location in memory. So the output here is going to be the total is 5. Now why is that? Because with this statement, with this code here, with the star PTR, what we're saying is the star is equivalent to say whatever is at the memory address stored in PTR, which in this case is going to be 5. So in our 16-byte RAM example, if this is theoretically where the value total is, then if we have assigned PTR to be equal to the memory address where total is, then star PTR is going to be equal to the value itself. This is what I want you to remember. The pointer contains the memory address. When you want to examine what is at that memory address, you put an asterisk in front of the pointer, which means whatever is at that location in memory. In this case, it's the value 5. So PTR is a pointer to an integer. PTR itself has some value, which is going to be a memory address, because it is a pointer. The memory address in PTR points to a variable, in this case an integer called total. The value of total is 5, which means at the memory address where total is located, you will find the value of 5. Therefore, the value of star PTR is also equal to 5. The technical term for the asterisk in this case is the dereference operator. The term dereference means to look not at the memory address, but rather at the value contained in that memory address. Now, a very important clarification. In this code, when I've written int total equals 5, and then I write int PTR equals address of total, the star character in this does not mean what is at the address of. The star does not mean what is at the address of. There is a difference between when you create the pointer, which is what we're doing here. We're creating the pointer. In other words, here the star just means that we're creating a pointer. If we didn't have the star, we're creating an integer. By putting the star, we are creating a pointer. When you use the pointer later on in the program, like say I have printf the value is %d, and I write star PTR, here is where it means what is at the address of. So this is important. Why are we putting the star here? Because if we didn't, what we're trying to do is we're going to try to print a memory address. By putting the star in front, we're saying, no, we don't want to print the memory address. We want to print what is at the memory address. The memory address is useless to us. We don't even know what it is. It is any possible memory address of your billions of bytes in RAM. We don't care what the memory address is. What we care about is what is located at that memory address. So we need to know the memory address in order to know what is at that memory address. So first of all, we create the variable called total. We give it a value of 5. Now we create a pointer called PTR, and then we assign that pointer the value of the memory address where total is located. Now, this line of code right here can also be written like this. It's the same thing. Same thing. These two lines of code are equivalent to this. You can do it in one line or two. So in this line of code, we're creating the pointer, and we're assigning it the memory address of the variable total. And in these two lines of code, we're creating the pointer called PTR. We're saying that it's going to contain the memory address of an integer. And here we are giving it the memory address of a specific integer, in this case, the variable total. And here we are printing not the memory address, but what is at the memory address. So the output will be the value is 5. And I'll show this to you in a sample program real quick. So let's do that. So let's say int total equals 5, int our pointer equals the address of total, printf, the value is %d. Now what do I put here? Think about it for a moment. What I want to say is, now I could put total here. That's one way to do it, and that would work just fine. But using the pointer, our pointer, I'm going to write, now I'm not finished yet because this is the memory address. I don't want to display the memory address. I want to print what is at the memory address. By putting the star in front, I'm saying what is at this memory address. And lastly, I'll return 0. Let's take a look at what happens when I run this. Do you see that? The value is 5. Because what is at the memory address contained in our pointer is the value 5. Our pointer is a memory address to the variable total, where the variable total is stored in memory. When we say what is at that address, we are saying the value 5. When you create the pointer variable, you use the star character to indicate that you are creating a pointer. When you use the pointer later on in your code, you use the star character, the asterisk, in front of the pointer to indicate that you are not talking about the memory address itself, but rather what is stored at that memory address. So let's go ahead and summarize these different points. So when we write int star PTR, PTR is the variable itself. This variable is designed to hold what? A memory address. Now, what kind of memory address? We are specifying that this pointer is going to contain the memory address of an integer. Now when we write star PTR, when we create the pointer, the asterisk or star simply means we are creating a pointer. If we didn't put the star, then we're not creating a pointer. Later on in the program, the star means what is at the address of. And it is called the dereference operator. Now when we write PTR equals ampersand total, ampersand total means the memory address of the variable total. Total, without the ampersand, means the variable itself, which is set to 5 if we write int total equals 5. So earlier we pointed out that any function, well, before I do this, let me go ahead and erase everything so that there's no confusion. So we're going to go on to the next part of this lesson now. So make sure you understand the two cases in which you can use the star. One is to create a pointer, and the other is to specify what is at the address of a pointer. When you say an ampersand, you are saying the address of. So as long as you can remember that, you're good, and now we can continue to the next part of the lesson. So earlier we pointed out that any function which returned a return value of a given data type could be used in place of that data type anywhere in the program. For example, because printf returns an integer, you can use printf in place of an integer anywhere in a program that an integer is expected. We did some examples of this earlier. The same concept holds true for pointers. If a pointer is set to point at an integer, that is, it is set to hold the memory address for an integer, then you can use that pointer with a star in front of it anywhere that an integer is expected. So let me demonstrate that so you don't get confused. If we create a pointer that is designed to point to an integer, then later on in the program we can use star followed by that pointer's name anywhere that an integer is expected. So let's do this. We're going to create an integer called total. We're going to give it the value of 5. Now we're going to create a pointer that is of the type integer, which means that this pointer is going to contain the memory address of an integer. Now how do we set that pointer to contain the memory address of the variable total? We do it like this. We say my pointer is equal to the address of total. Now anytime in our program that we might expect an integer, like say this printf statement, we can use our pointer with the dereferencing operator, the asterisk. We can even do well, let me run this as a program real quick to show you. Let's just so let's run this program and take a look at what happens. The value is 5. See, our printf function expects an integer here. Because we are saying that my pointer is pointing to an integer, then we can use star my pointer anywhere that an integer is expected. We can even do mathematical operations on it. We can, for example, let's create another integer called new total. We'll give it a value of 10. Now let's say that for the integer that we're going to send to the printf function, it is going to be the sum of star my pointer. What is star my pointer? Star my pointer is whatever is at the address of my pointer, which in this case, since my pointer contains the memory address of total, that value is going to be 5. So that's 5 plus new total. So here, %d is expecting an integer. When you add two integers together, you get an integer. So I can use star my pointer just as if it was an integer. Watch this. If I run the program, I get the value is 15 because I have added 10 and 5 together. Star my pointer is saying whatever the value is at that particular memory address, which is going to be 5 because my pointer is the memory address of the variable total, and new total is simply set to 10. If I were to write my pointer plus 20 and run this program, I get the value is 25 because 20 plus 5. So you can see then that I can use star my pointer anywhere that I would use an integer. So remember that star my pointer is an integer in every sense of the word. It is the actual binary sequence, the actual integer that was stored at that location. It has the correct size, data type, everything. Let's take a look at that in memory. So if we write int total equals 5, and then we write int my pointer equals the address of total, then how would this look in memory? I'll show you. So let's suppose at position 8 in memory we have, let's assume total is 1 byte in size, just to make this easier to understand. Then here's how this works. My pointer is going to be the memory address. Star my pointer is going to be the actual binary sequence located at that memory address. So that is an integer. So of course star my pointer is an integer. That's why you can use it anywhere that an integer is expected, because it is an integer. The reason it is an integer is because it is pointing to the memory address of an integer, and it is told to be treated the same way as any other integer is to be treated. So it is not merely that star my pointer is like an integer, it is an integer. It has the same size as an integer, the same data type, everything. So if you have any questions on this lesson, feel free to ask, and I hope you enjoyed this lesson.